Good evening, sir.
Also, good evening. Okay, so four of you are present. Let me actually, the session was to be conducted by someone else, but there is a little bit change in the. So I'm continuing with. Now we have gone through that PPT. Now that PPT will apply in ETAB on our already prepared model. Clear? So that the continuity will not be uh, disturbed. Hello.
Yes, sir.
Yeah.
Yes, sir.
Yeah. So otherwise, you were going to start with some design and then we'll be coming back. But I discussed with Anil sir, and he said that okay, continue the sessions for one or two sessions, and then next schedule will be started, or the module will be started. Okay. Uh, so let us go. Let me present first because I always forget to that. Okay, so share. So the screen is shared. Okay, how many are there? Eight, nine. Okay, people are joining. So yes, Sulaka has also joined. Okay, so let me go to ETAB model. So I will pull down this. Double click on that icon and wait for initializing process. And we are having the model, let's say open existing model. Okay, so we had the model that was for where we have left it. Let me go to my computer and that, let me go to D and ETAB and okay, that may be here. I think this was our model, no? What was the name of the model? I think it was residential building
Yes, sir.
B19 or 01. So this was the model, I think. Okay, check करते हैं. So B19 or 01. I think this is the model that we were looking for. Let
Yes, sir.
me let me go to this. Okay, if I go to that and if I see the load patterns, yeah. So this is the model, definitely. Okay. Now just see that here we have gone for developing the model. If I go to load pattern, you can see we have so dead load and live load was already there. We have defined STL, and the first thing that have to do is unlock the model so that I can change into it. So if the model is locked, then you cannot go for any editing. That is the only case. So now here in define, I will go to define and I will go to now. Okay. So what we are now going to do? We are going to apply lateral load that might be registered by this building. Uh, due to earthquake. Now, in earthquake, we will be going for equivalent static load method and uh, dynamic analysis, that is linear dynamic analysis, that is with the help of a model superposition and response spectra. So that we are going to apply. Previously, what we have done everything manually, but in response spectrum, we have assumed that pre-vibration analysis data that was done by some software. Now we will be going for that pre-vibration analysis also. Okay, so you have to go to define under this load pattern, click on it, and here you will see that now I'm going to type earthquake data, and that is earthquake in X direction. Okay, so I will say that EQ in X direction, or you may say any name. So EQ in X direction is my uh, earthquake data for static load conditions. So what is the type? Type is lateral, and it is, you can check it over here. So here you can find the name as seismic,
Yes,
because
sir.
it is a seismic load. Hello.
Yes, sir.
Yeah. Now you can see that self-weight multiplier, except dead, everywhere it will be zero. So this is zero. And now you can see over here, auto lateral load. Now this facility is provided. Now you can say that you can do it manually. So if you find equivalent static load at every floor manually, then you can apply manually also. But there is another facility that this software ETAB will calculate all the lateral loads. The only thing is that you have to give the instruction through this auto lateral load about the code, which code that which analysis code that you are going to use. So we are going for IS 1893. So you can check it and see that the code that you're using, which one? This.
This one, sir.
Yeah. Now in versions, if you are having ETAB version, say 18 or 19 or anything more than 17, so then you might get it 2002 and 2016. It is up to you. But even if you use 1893 2002, that is also enough. Now after doing this, I will just add new load. Then I will go for earthquake
I
in
axis.
Y direction. Okay.
Yes,
Type
sir.
will be seismic, self weight will be zero, and 1893 it will be same. And
Add.
add new load. Clear over?
Yes, sir.
Now he will ask you for some changes as per your choice, because in 1893, if you want to use, there are many parameters that you have to define. Okay, so that facility, so highlight that and go to modify lateral load, right?
Yes, sir.
So if you can click on this, you will see this is one more pop-up window will come in front of you, and it will ask you to fulfill that. Now I want to apply this earthquake X EQX category in X direction, so I will uncheck all others except X direction. Clear?
Clear, sir.
Then under zone category, what was the zone that we were going to use? So we were in Bhuj, so that was 0.36. Yes.
Yes, sir.
Then you may go for user defined. Let's say if you are very uh, prompt enough, or you are more expert in analyzing the Z factor, then you can use any Z factor. Or if you want to use code, you can use this. But in code, this is for second category, second zone, third, fourth, and fifth.
Fifth.
Out of that, whatever is your choice, that you can go for. So let us click on point 36. Now soil type, you know that there were three soil types, so 1, 2, and 3. In our data it was uh,
Second one, sir.
an importance factor. Now this importance factor For residential, it is 1. And if the building is residential and uh, number of number of people that will be there is more than 200, then you may go for 1.2. But right now we are using importance factor as 1. Clear?
Clear, sir.
So here you have chosen the direction. Here you have chosen the parameters for zone. So whatever the zone factor, then here the soil type, it may be 1, 2, or 3, and importance factor. Now here you can see a story range. Normally you can go with base to terrace. See here, you are not applying the lateral loads on terrace, on the water tank bottom or top. So it is up to you. By default, it will go for lower to higher. So it's your choice. So I'm applying up to terrace. Okay. Now time period. Now there are three choice. Either you can go for approximate, and in this you have to mention whatever approximate time period that you are using, or you may go with the help of your calculation. So here you can calculate it by that formula 0.09 h over root d. Clear?
Yes, sir.
Or you may be asking program to calculate. Now, how this program will calculate? Because in its inbuilt category, he will find out all the codal provisions that are used in 1893, and in that he will see that formula and he will calculate it. So it is both you can use. Either you can calculate on yourself or you can ask program to calculate. Clear?
Clear, sir.
Then this is about factor. So this is a response reduction factor, and by default it is 5. But if you want to change it, whether 3, 4, or 5, but as per codal provision, we are going to use it as 5. Clear?
Clear, sir.
Then click
Yes.
OK. Click OK. Then click on EQY. Again, do the same thing. But now I will uncheck this. Only y direction. Then
Yes, sir.
z equal to 0.36. Here it will be second. Here it will be 1. And here it will be terrace. And program calculated. And r equal to 5. That's all. Click OK. Now you don't have to do. Everything will be calculated by this software. And it will give you the base year. It will give you how it is distributed. आसान है ना? हेलो.
Yes, sir.
Yes, sir.
इतना ही करना है आपको, इतना ही करना है. बाकी सारा चीज इनबिल्ट फैसिलिटी विल बी टेकिंग केयर, एंड यू विल हैव टू जस्ट फाइंड आउट द रिजल्ट्स. तो आप में से बहुत सारे लोग बोलेंगे सर इतना आसान था तो क्यों वो मैन्युअली करने को लगाया.
जरूरी है सर वो
सर
भी.
कॉन्सेप्ट क्लियर हो जाएंगे सर, उससे फिर कभी डाउट नहीं आएंगे.
Yes, क्योंकि without understanding, see, the software will not make any mistake, because inbuilt facility, it has been stored in his memory, and software will not do any mistake. But giving the input, if you have done something wrong, you will not be in a position how to justify, or whether whatever results you are getting are correct, or you can believe those results or not. All that thing will be beyond your control. And that's why actually we used to go through that PPT, and then we ask you to go over here. Okay, then one more thing that you can see over here, somewhere it is mass source. Click on it. Now You might wonder only giving the codal parameters that whatever may be the direction, then Z, then I, R, and range, how it is finding, how it is calculating the mass, how it is calculating the lateral force. So it will take the data with the help of mass source. Okay. So by default, there is this MSRC1 as a mass source. You can click on this, modify show mass source, click on it, and there are various facilities available. Out of that, you may change the name or you may keep it as it is. MS means mass and SRC means mass source.
Source.
So mass source 1, that is the name given. But if you don't like this, you can change it over here. And you can see the mass source in this inbuilt software can be found out by various methods. So element self mass, additional mass, specified load pattern, adjust diaphragm lateral mass. These are various. Out of that, what we will be doing, we will be asking him to specify through load pattern. What we have done, we have calculated seismic weight, and then the seismic weight was divided by gravity, acceleration due to gravity, and we found the mass. Okay, so for that, how you can calculate the weight? By specified load pattern. Now, once you click on this, you will see that this load pattern is available. See, if I don't click on this and I click somewhere here, this is not available. Are you getting it?
Yes, sir.
So it will be available only when you will click on this specified load pattern. Okay. And now you can see and you can apply your codal provision. So so dead load, that is in this R case, this dead load is what? It is self weight. So कितना self weight लेंगे? आधा लेंगे, पूरा लेंगे, क्या? Hello,
All, sir.
full. So the multiplier will be 1. So under dead category, your multiplier will be 1 and you will add. Okay.
Yes, sir.
Then I will go for SDL. So SDL is floor finish and any weight which is permanent but not considered in model. That means not model by the drawing it. That means wall or any other. So कितना लेंगे वो? 100% या 50% या 20% या you will leave it? Hello,
100% पूरा लेना.
100%.
Yes,
So
sir.
now live load. Live load कितना लेंगे?
100%.
अरे
25 or 0.
what is percentage? How you are calculating seismic weight?
Sir,
Some
50% up, 50% down.
50% up, 50% down. That is how you are calculating. But how much percentage of live load you are considering?
50%.
Either 25 or 50. That
Yes, sir.
depends.
Above 3 kilonewton, 50%. Below 3 kilonewton, 25%.
Okay. Now हमारा केस क्या है? Except that passage, everywhere we are having live load less than 3.
Yes, sir.
So we have to go for 25%.
Yes,
So
sir.
I will write it over here as 2.5. Clear हुआ?
Yes, sir.
So now the mass source, he will calculate full live load and he will consider only 25% because you are saying that in my case you use 25, right?
Sir.
Yes, sir.
Then you are going to include lateral mass and you are going to lump lateral mass at story level. Okay. And then click OK. So the two checkbox are clicked or OK. You can say have a click over here and click OK. So the mass source that you have converted as per your choice, or you may create your own additional name, not necessarily this, but normally I used to change into this only. Clear?
Yes, sir.
So now he will be in a position to calculate seismic weight of the entire structure, or he will be in a position to find out seismic weight of every floor. WI, W1, W2, W3, W4 and sigma W. पता है ना?
Yes, sir.
ये भूल गए तो यहाँ पे मुश्किल हो जाएगी, इसीलिए वो लिया है. Okay. Now your static load case is 100% applied. You don't have to do anything. You just have to go for analysis and get the results. But we are not going for analysis right now. We are going to define the response spectrum or dynamic case also. How we will be defining it? पहले तो response spectrum इसको बताना पड़ेगा ना हमें.
Yes, sir.
So that can be defined with go to define and go to function. In this function, you will go to response spectrum. Now this time history, don't go into that. Go to response spectrum, click on it. Now he will say that, okay, I have one. By default, I am having one. So if you are not going to give me any instruction, I will use this. Would you like to use this? Because this is, don't know what is this, ASCE 710. Okay. So this is for American. So by default, they have given you the function response spectra, which is used in ASCE 710 code. So here I will say that I'm not interested in that. Go for which one?
NBC, IS 1839.
Right?
Yes, sir.
And then add new function. So यहाँ पे now he will ask you the name of the function. You can say anything, but I will say IS function. You may say function 1, function 2, or you may say with your name also. That is up to you. So damping 5%. Seismic zone, which one we are considering? 0.36. Soil type 3. Okay. And linear X and linear Y. तो ये फंक्शन यहाँ पे तैयार हो गया है ना, वो वही जो IS 1893 में जो हमने PPT में देखा था.
Yes, sir.
So that is okay. And then you can delete this because now you don't need this and you don't know what is this. So better to delete it. But it cannot be deleted unless you will define one more function. Okay. So here now you have defined IS function, which you know, and you have defined it with 1893 codal provision. So the function is defined. Now this function is applied in X direction and in Y direction, right?
Yes, sir.
So how you will give the instruction to the software that whatever function that you is to be and what's in Y direction. So that you can do with this. Go to define and now go to where load case.
Yes, sir.
Clear? So under load case, you will see that whatever primary load cases up till now you have defined are there, and these are going with linear static. So what is the load case type? Dead load linear static, live load linear static, STL linear static, EQX is also linear static, and EQY is also linear static. Now you you have to define a dynamic load case, and that you can define with add new case. बराबर ना?
Yes, sir.
So click on add new case, click on it. Now this is your dynamic case. Now this you want to apply in X direction, and you are going to use a response spectra. So that's why I will give the name as RESP response, or let's say RS1, or you can say normally I say uh, spectra, so spect or RA spectra X. This is my name, or you may say spec X, so that you know that it is a dynamic load case that is applied in X direction and with the help of response spectra. Clear?
Yes, sir.
Or you may say anything, but then you have to remember it. I don't want to remember, so I
Sir,
say
RSX. RSA-X, response spectrum analysis X.
okay. So RSA X. So you can say RSA X. That is also good, but uh, you have to you must have some reference so that you will not get confused. Okay. Okay. Now this is the name. Then load case type. Now, what is this load case? Whether it is linear static? No. Then what is the case? It is a dynamic case, right?
Yes, sir.
So you have to click over here and see. Now in this software, you can apply linear static, non-linear static, non-linear staggered construction, response spectrum, time history, buckling and hydrostatic. Now इसमें से वो कौन सा आपको लगता है? This is response spectrum. Clear?
Okay.
देखो ये this is very important because many times people forget over here and by default it is there and you can see then you say that sir वो नहीं आ रहा आपने जो दिखाया वो नहीं दिख रहा है नहीं दिखेगा unless go to response spectra. देखो अब बदल गया ना नीचे सीन.
Yes, sir.
So
Yes, sir.
first name and then go for load case type is a response spectra case. So response spectrum type. Then now here you can see a load type, load name, function, and scale factor. Now first I will click on add. Now which response spectra that you are using? Acceleration response spectra. So the case is acceleration, right?
Yes, sir.
Then what is the response that you are going to find out? That is U1. So you are going to find out acceleration response in one direction. You can see 1, 2, 3, R1, R2, R3. That means U1 means it is a response in X direction. U2 means response in Y direction. U3 means response in Z direction. Then R1 means rotational response about X. R2 means rotational response about 2. And R3 means rotational response about Z. So you want to apply it in X direction. So U1. Okay. Clear?
So,
Yes, sir.
Then this function, which function that you want to use? IS function. Right?
Yes, sir.
And here you can choose arbitrary. I will talk about this later. You just say 1000. So arbitrary scale factor that I'm using, because here you can see it is in mm per second square, and that's why I am using 1000. right? Then model case, it is a model combination that I have talked about, that combination, CQC, and directional combination, SRSS, and then everything is okay, click OK. So dynamic load case in X direction for uh, finding out SA by G in X direction is complete. Now it will use whatever response function that you have given, 1893, etc. Now same thing, you have to go for Y direction. So add new case. Now,
ऐड कॉपी
yes,
ऐड कॉपी एक केस कर देते सर, फिर थोड़ा चेंज करो.
नहीं, add new case करो, practice करो ना,
यस.
और ऐसे
वाई.
Y response spectra, then add acceleration. Now here I will go for
यूट्यूब.
direction 2. Here I will go for IS function 1, and this one I will change it to 1000. Okay. Then remaining things as it is. Click OK. क्लियर हुआ?
यस सर.
अब इसके बाद आपको कुछ नहीं करना है. राइट नाउ,
यस सर.
नाउ थोड़ा एक कंसेप्ट है. we talked about rigid body. See, one more thing is left, and that I want to clear. ये ध्यान से देखो, this nobody will tell you except me. I'm not getting it, so I will have to go ahead with some different thing. Yes, that is why I was not able to. Let's say this was your 1B. Right. Similarly, you will find all this, but I don't want to have a complicated figure like this, because I just want to share the concept. So what you said, that instead of this you are going to consider mass over here, right? Yes.
यस सर.
And you say that the force will be applied due to earthquake in X direction like this, and you will find this mass something like this. So this leg consists of equivalence of all these 4 columns, and you say that it will vibrate like this. Okay, but actually you are having entire mass something like this. Right? Hello.
यस सर.
Now you want entire mass to move in this direction or in this direction, just like this. So this is, you can say that it will move something like this. Right? Or like this. So that is called a entire floor will be considered as rigid body. rigid body. Now, how you will assure that entire floor is not getting bent like this? A floor will be a straight like this. How you will assure that this will be the performance and not this? Yes, so that is that rigid body deformation of the entire floor as one unit is achieved through diaphragm. Okay, mathematically it can be achieved by creating a diaphragm, and that creation of diaphragm you can get it through this. Go to define and go to diaphragm. So click on the diaphragm and you will see that this is the diaphragm. Now this diaphragm you can click on, you will see that diaphragm name is D1 and there is rigid and semi-rigid. Now semi-rigid means it may have some deformations in vertical direction. So it is not 100% rigid and this is 100% rigid, right? So you want this diaphragm to act like D1. Okay. Which one? All these. See, this one, this one, this one, this one, this one, this one, and this also. Length. Right? All this you want to act as a rigid body, and that can be assured with selecting diaphragm. So you have to go to, let's say we'll go to first, and in first I will select 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. Now, actually, this is horizontal in our case, but actually it is sloping. So I will not select this. All horizontal floors, you can see that I have selected except this staircase. Clear?
Yes, sir.
Hello. Right? इतना क्लियर हुआ क्या?
Yes, sir.
Yes, sir.
Yes, sir.
Now I will, after selecting, I will go to assign, and what I have selected shells. So I will go to shells, and under shells, I will try to see diaphragm. So I will click on diaphragm, and then I will click on D1 because I know that D1 is a rigid diaphragm, and I will click OK. Clear हुआ क्या हुआ?
Yes, sir.
Right? So every corner is connected just by some. These are just for conventional. The meaning of this is that now the entire body will have a translation. It will not have bending about x or y out of plane bending. Right? Clear हुआ?
Yes, sir.
Clear, sir.
So similarly, you can select 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. I will not select this. Go to assign, then
Cell.
go to shell,
Diaphragm.
and click.
D1. Okay.
Now, in many videos, they will say that select all the slabs and give the diaphragm D1 to everybody, everything. But I will not. I will see the see here this red dot, which is imaginary for your understanding, is created, and entire all the corners are rigidly connected to this body. So the movement of this body will be exactly, so the movement of this point will be exactly like this, D1. That is the concept that is showing you a rigid diaphragm. You can go up and select. So I'm just selecting, try to see, and after selection, I'm doing the same. Go to assign, go to shell, under shell, go to diaphragm, and click D1, and okay. Then you can go up, then select 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You might find it repetitive, but do it separately, because that will define clear understanding in software input. So there will be less chances of committing any errors or mistake. Or after you become confident enough, you can go and select and you can apply. Right? प्रैक्टिस करना है, शॉर्टकट नहीं लेना है.
ठीक सर.
Yes, sir.
Go to assign, go to shell, go to assign, shell, diaphragm, E1. Okay. Then you can go to assign, clear display of assign, and if you go up, now you are not applying earthquake to this, so you may delete it. So what about plane? Yes. यहाँ पे क्या करना पड़ेगा? See, do you want this to move as a rigid body or not? That is up to you. Yes. क्या करेंगे? See, अगर ये चीजें अगर नहीं सोचेंगे ना, तो you will not be in a position to develop yourself. भले भले आपका आंसर गलत है. Try to imagine what will happen. See, the first thing is that do you want the first thing is that where it is placed, at ground level? Yes or no? This is ground level, no?
Yes sir.
Yes, sir.
Now,
Yes, sir.
now do you want all these elements to move as a rigid or not? अगर आपका आंसर है yes, then how you will give the instruction to software. और अगर आपका आंसर है no, then how this software will understand that you don't want this to move as a rigid body. देखो, सवाल मेरे आपको बहुत गंभीर लगेंगे, आंसर बहुत आसान है. अरे भाई, व्हाट इज दिस? Yes, this is the surface of Earth. Yes or no?
Yes, sir.
Yes.
On this, you have built a structure something like this. Yes, yes or no?
Yes, sir.
तो ये रिजिड है ही, आप क्या करेंगे, माने नहीं माने कुछ फर्क नहीं पड़ता, ये रिजिड है ही। आई बात समझ में?
Yes, sir.
तो आप
ओके सर,
तो
यस
कुछ फर्क नहीं पड़ने वाला। ये ऐसा थोड़ी है, यहाँ पे बहुत बड़ा वॉइड है क्या? This is a surface, so this is a surface, Earth surface. So it is rigid definitely. So whether you consider this rigid or not, it will deform just like a rigid body. Clear?
Yes, sir.
क्लियर सर।
अब मान लो उसके बाद में you might have some doubt. तो क्या करो? Select करो. Right? आपने क्या किया? सब कुछ सिलेक्ट किया. After that, you can go to assign, but now don't go to shell because there are no shells. So you
Frame.
will go to joint, and under joint, you can see there is a diaphragm, and
D1.
you can apply. अगर आपको if you are not sure कि ground will move as a rigid or not, and you want the ground movement to be rigid, you can apply it. And even if you don't apply, the ground will move as a rigid only. Clear?
Clear, sir.
बट वो कंसेप्ट जब तक नहीं समझता ना, तब तक उसका आंसर नहीं। इसीलिए मैंने बोला कि व्हाट यू नीड, व्हाट यू वांट। अगर आपने ये रिजिड डायफ्राम इसे असाइन नहीं किया तो भी वो रिजिड ही है ना।
Yes, sir.
Like a
Yes,
rigid.
sir.
यस
Frame.
Yeah, it will move like a rigid. See, I'm talking about plan. I'm not talking about vertical. But see, that is not the case over here. See, this is something 3 meter above the ground, and these are the slabs, right? And these slabs may see. Let's say this is your slab. I'm talking about. Let's say I'm talking about thickness. Okay, this is your slab, and it is applied with this force. Because of this force, it may bend like this. हो सकता है ना अप्लाई करने के बाद?
Yes, sir.
ये ऐसा ऐसा हो सकता है ना? You don't want this movement. You want this to move in one line. This or this or this. And that's why you are saying that this is rigid. This is rigid. And that rigidity is understood by this software by applying diaphragm rigid constraint. Clear? Okay, so after this, nothing is left except combination. But we'll go for combination in next session. Today, we'll try to analyze the things. So I will go to assign, clear display of assign. Okay, so what is left now? See, I have given you information about material properties, section properties, then diaphragm, then pier level I have not given, I think. और ये मैंने बताया है ना आपको?
Yes, sir.
Yeah.
Peer level add किया आपने.
Yeah, peer level बताया है. So I have given information about functions, mass source, then okay. So this is the model case. So I have not, I think, explained you. So if I click on model case, and if I see what is by default, it is over here. And if you see show, then you can see that the name is model case name is model. Then model case subtype is eigen, that is eigen free vibration analysis or ridge vector free vibration analysis. So ridge vector is something different. So you don't want that. You want a free vibration analysis. That's why by default it is eigen always there. But if you want to check, you can check it with this. Now you can see over here, maximum number of modes are 12. So by default, this see if you do not give any instruction to ETAB, he will give you the model analysis or mode shape up to 12 numbers. Clear? Minimum will be 1 and maximum will be 12. That is important for you. Rest of the things are a little bit advanced. So frequency shift and cutoff frequency. So agar aap dynamics analysis, if you are prepared to study dynamic analysis, there you will find this. But right now you put it over here as 0 as it is. Here you can change number of modes you desire. Why we want to go for additional number of modes? Can you correlate this? Yes, anybody? आंसर देना पड़ेगा यार, मुझे ऐसा नहीं चलेगा. हमने क्या कहा था, कितना डायनेमिक एनालिसिस मोड चाहिए, how much mass that you should get activated in number of modes?
90% up to 90%.
Okay, so most of the time you will see that 12 number of modes will if you analyze, then that is sufficient. But sometimes after 12 modes also, if you are not getting 90% mass activated, then you have to go for additional modes. Rough calculation, I will say that how many floors are there? 1, 2, 3, 4, 5, 6. So 6 numbers are there. Every floor will vibrate in X direction. It will vibrate in Y direction. So number of modes will be 2 per floor. So 6 into 2, 12. So in our case, 12 is sufficient. Or you can check anything. You can ask him anything. Software has a capacity to carry out model analysis to 100 mode shapes also, right? So you can find out. So let's say you are not interested in 12 because you can say that sir, 5 modes are more enough. So let us make it 6. You can do it. That is what you can go ahead. Then, so I have gone through mass source, then model case, load pattern, then load cases, load combinator. This is to be done later on, but today I'm not going for load combination. In tomorrow's session, we'll go for load combination. Right now, I'm ready with analysis, and now I can analyze the structure. So before that, I will go to analysis and I will check the model. So model has been checked, then no warning messages. So okay, so I'm ready. So you can go for analysis and you can go for run analysis. So it is carrying out the analysis. You can check it over here. So the analysis is carried out. Now it will analyze for lateral loads also due to earthquake. Okay. So the analysis is complete. I will go to this and the one thing that I want to do, or I want to check that dynamic base shear and static base shear, they must be comparable. So I have to compare that, right? So for that, you will go to display, then show tables. In show tables, you will go to analysis. In analysis, you will go to results, and in results, you will go to reactions, and in reactions, you will go to base reactions and click OK. So how many load cases are there? जितने प्राइमरी लोड केसेस है उतना आपको रिजल्ट मिलेगा, और ये दो कॉम्बाइंड केसेस है. सो आउट ऑफ दिस आई एम नॉट इंटरेस्टेड. आई एम गोइंग टू राइट क्लिक ऑन दिस, provide curtal, then I will go for EQX, EQY, and RSAX and RSAY. That's all. And now you can see this is my VB. How much it is? 1372.8188. So I think I will have to write it somewhere. Or you can write it and give it to me. Hello. उतना काम करेंगे?
Yes, sir.
Sir.
Yes, sir.
So this is, see, this is your static base, static lateral load case applied in X direction. So EQX will give you a static base shear or equivalent static base shear, and that is something around 1372.8188. Right? Hello.
Yes, sir.
And dynamic analysis. Equal to
Yes, sir.
786.3184. Clear? So what you have to do? You have to divide 1372.8188 by 786.3184. Right? And that will be your scale factor for RSA X. Now for RSA Y, you can see that this is your base shear. How much it is? 1063.4388, and RSA Y is giving you 869.6142. Clear?
Yes, sir.
So I think it is better to write it for here. So for EQX, what I will write it as 1372.8188. 8188 and divided by spectra X. So RSA X, that is 786.184. Right?
Yes, sir.
And similarly for Y, I am getting 1063.43, 1063.4388, 4388 divided by 868. So 868.6142. Right?
Yes, sir.
Write down that, then we'll close this. Now after that, I will again unlock the model because I want to make the changes. So I have to unlock, otherwise it will not give me any facility to edit, right? Okay, then I will go to this define in load case. Under load case, I will go to this, then I will go to show, modify or showcase, and here I will write that. So what was that? So what I will do, I will write it over here as shift. So 1000 multiplied by 1372.8188 divided by 786.184. Okay. So I am asking him to calculate. थोड़ा मैं lazy रहता हूँ. I do everything by that. So you are getting 1746.18. उतना ही आ रहा है ना?
Yes, sir.
Yes,
See,
sir.
this ratio multiplied by 1000, because originally you have used 1000, right?
Yes, sir.
So the scale factor that you are getting is 1746.818. That is for spectra in X direction. So spectra in Y
Y
direction,
direction.
the same thing. But here you will have to do 1000 multiplied by 1063.4388. 4388 divided
मल्टीप्लाई
by,
नहीं हुआ, 8 हुआ है इधर.
yes,
मल्टीप्लाई नहीं हुआ, 8 लिखा गया है. हाँ.
yes. So 1000 multiplied by 1063.4388 divided by 868,
0.6142.
6142. Okay.
Yes,
And
sir.
then I will enter and he will calculate that 1224.29.
Yes, sir.
And okay. So this is done. Then I will remove that because now I don't need that, and I will close it. Okay. So again, check whether the things are correct. वही प्रॉब्लम था, मुझे ऐसा लगा. कितना आया था?
Sir, 1746.
1746.
46.
0.18.
0.18.
नहीं, एक मिनट मैं वो वापस करता हूँ. मुझे वो डाउट आया था इसीलिए मैंने वो देखा. See, I am getting it. So go to define, then go to load cases, and in that go to that array modify. By 1372.8188 divided by 786.184 and enter. Then you can see, click OK. Then go to this, then 1000 multiplied by 1063.4388 divided by 868.6142. Okay, so enter. Okay, then click OK, then click OK, and then you can say You can do it like this, right?
Yes, sir.
So now save. So I'm saving, and again I'm checking that whether that is saved or not. Now it is saved.
Yes, sir.
Okay. See, these are the things where many times we make some sort of error just because of we are hurry. We are always in hurry. ओ हमें वो आखिरी आखिरी एंड तक जाने में, और जाने के बाद क्या करेंगे अगर पता नहीं है तो वो फिर तो अच्छा है, go through the steps. Okay, now it is saved, and now I will go for analysis. And now I am not going to check the model because I know that it is correct and I have not changed anything, right?
Yes, sir.
So you can go for analysis. So it will analyze it. So that's why initially that 1000 is considered. Okay, so it is. Now you can go to display show tables, and in show tables you can see base reaction. Click on that, and now you can see 1372.81 and this 1373.05, almost same. तो उतना फर्क चलता है. EQI 1063.4388 and 1063.4356. So now you can say that your, and this is called what, scaling up the dynamic results, right?
Yes, sir.
And now after that, how much time? Okay, there is a time. So now I can remove it. Now I don't want that. Okay, अब क्या करना है? अब क्या चाहिए? मोड देखना है ना, वाइब्रेशन मोड शेप.
Yes, sir.
यस
ग्राफिकली देखोगे क्या टेबल में दिखाओ?
दोनों तरह दिखा
पहले
दीजिए।
ग्राफिकली देखेंगे फिर टेबल।
ये बंदा यही बोलने वाला, ये मुझे पता था. ओके, लेट्स go to display and see deform shape. See the mode shapes you will get under this deform shape. Click on it, and here you can see that mode is highlighted and mode number 1 is highlighted, and apply. And okay, actually, okay, so let me go to that. So I will highlight this. See the result in this window. Okay, so I'm making this window small because I don't want to see the mode shape in plan. I can see the mode shape in elevation, vertical elevation only. So you can go to display, deform shape. So click on mode. So mode number 1 and apply, and okay. Start animation. See now your mode number 1 is under torsion 5, and that is what I always say, that it is a property of structure. Whatever sizing of columns, layout of columns, orientation of columns, and this whatever that you have done is like this. Okay, so this is how you see your mode number 1. So mode number 1 will be always of larger time period or greatest time period, longer time period, and lowest frequency. Clear?
Yes, sir.
So this is your mode number 1. Let us go quickly and see other modes. Deform shape. Go on mode number 2. This is your mode number 2. Clear?
Yes, sir.
वो
Clear.
वो जो हमने देखा था ना, वो ऐसे वाइब्रेशन, फर्स्ट मोड, सेकंड मोड, थर्ड मोड.
Yes, sir.
So this is your mode number 2. Let us quickly see mode number 3. So this is your mode number 3, which is a mixed mode. It is called a mixed mode because it is having a linear deformation in x direction and a little bit in y direction. हो रहा है ना?
Yes, sir.
Yeah. And now I will just go for one more shape so that you will understand the difference. So let us see that. Yes,
Yes, sir.
पता हो रहा है कैसे है? ये है ना ऐसा?
Yes, sir.
ठीक है, ऐसा है. So all this, you can see, it is a property of the structure, and still, if you don't believe it, you might say that, sir, ये कुछ भी किया तो ऐसे ही हिलेगा. Do you want to see it, how differently it will behave if something is deleted? Yes.
Yes, sir.
Yes, sir.
Okay, so I will go to this. See, this is our structure. Okay. Now what I will do, the first thing is that I will go for all story, and here I will choose this column and this column, right? So the columns are considered, and now I will change their orientation. So go to assign and frame. I have to unlock it, otherwise I cannot do that. Okay, so go to assign and go to frame, and under the frame you will see local axis, and here you can see I will change the axis as 90, right? Apply. Okay, and go to plan and see first. ओके, मैंने इसका ओरिएंटेशन बदल दिया, राइट? हेलो.
Yes, sir.
Yes,
Yes,
sir.
sir.
And I will also select this this wall, and you can see in 3D, or let me do that by going in clear display of a sign and select clear selection, and Let us go to terrace. See, I will go in elevation number 3. So elevation number 3, and in elevation number 3, what I will do, I will select all. Okay, clear? And after selection, I will delete them. And now if you see the plan, clear one. So see what I have done. I have just changed the orientation of the two columns, and I have deleted a slab over here. I mean wall over here. Yes.
Yes, sir.
Now just go and analyze. Now that base shear might have changed a little bit, but you can check it, and you can consider it as your exercise. I will go to 3D, and I will go for undeformed, and now I will ask to show me deform shape under mode number 1. Pehle it was torsion. Huh? Now it is a torsion, but it is a little bit different. Let's go for second. So go to display, go to deform shape, and go to second, and apply, and close. See now the shape. Pehle it was in y-axis, no? Now it is in x-axis.
Yes, sir.
Hello. See what I'm trying to make a point is that, see, the vibration analysis has nothing to do with earthquake. It is a property of the structure. Whatever is the layout of the structure, what are the sizing of columns, how the orientation of column is there, and based on that, it will calculate M and K, and based on that, it will calculate omega 1, omega 2, omega 3, etc. So you can see that. And now third mode. Let us go for third mode. See, in our earlier case, the third mode was a mix in x and y direction. Now it is purely in y direction. Clear हो रहा है ना?
Yes, sir.
So this is how you can change the
Yes, sir.
performance of your structure. Yeah. Yes. Any doubt, please? Clear हुआ?
Yes, sir.
Okay. Now See, you can exercise with the help of changing the orientation of this column, changing the orientation of this column, this column, this column, or you may go on adding the column over here, over here, over here, and see what changes are getting you are getting in free vibration analysis. So that will be a point of study. See, just modeling the structure and going for see here dynamic analysis as well as equivalent static analysis method is entire calculation is a responsibility of your software. So why you don't go for finding out different how the mode shapes are getting affected by your uh, configuration of the structure, sizing. You may go for sizing of the columns, change the sizing of columns, or you may apply, say, L type of shear wall over here, L type of shear wall over here, L type of shear wall over here and here. Or for this wall, you may apply instead of this column, you may apply a wall over here and see the changes. See that will help you understanding the dynamic behavior of the structure, and that will increase a confidence in you. See डेफिनेटली मैं आपको एक क्लिप देता हूँ, एक क्लू देता हूँ. अगर ये जो शेयर वॉल है ना, ये शेयर वॉल, अगर ये दो कॉलम निकाल के आपने ये शेयर वॉल यहाँ पे अप्लाई कर दी, then you will see that your first mode, which was in torsion, will be eliminated, and you will get a first mode in y direction and second mode in y, and you can find it. Okay. Now all these things you can get through your display show table, and under that, instead of the base reaction, now I will go to model results, and in model results, if I go for model period and frequencies, you can check it over here. So these are now there are only 6 mode. Why 6? Because you ask for 6. Clear?
Yes, sir.
So mode number 1 is having period equal to 1.179, frequency, which is this natural frequency, then this is circular frequency, and this is eigenvalue. Forget about eigenvalue. If you are not in if you are not studying structural dynamics, you will not understand what is this. It is just square of this circular frequency. You can check it. But this is your mode. So the first mode, you can see always you will have a largest time period as your mode number 1. You will see the smallest frequency is this, and it is in ascending frequency.
Clear, sir.
Clear? So this is your modal periods and frequencies. Now we'll go one step ahead. Let me close this, and we'll go to display and show tables, and instead of this, I will go for modal participating mass ratio, and this is what you are getting. See, this is your mode number 1, which is having period equal to 1.179, and it is having UX. Now UX is, now this is mass ratio. So when your structure is vibrating in X direction, the modal mass that is getting activated in vibration in X direction is 0.0781. That means 78%. Clear?
Yes, sir.
Now, if you see RZ over here, See, this is your RZ. Now this RZ is also Z in rotation about Z axis is 0.8073.
Yes, sir.
Clear or? And now this, as per code, this is not allowed. The code has disallowed a first mode in torsion. Code says nothing doing. आपको first mode torsional behavior में जाएगा तो entire, see, 80% mass is getting activated in torsion, and it will twist your building and it will collapse immediately without giving any intimation or warning. So आपको पता भी नहीं चलेगा. जैसे the building is subjected to earthquake, the entire building will get collapsed because 80% mass is getting activated in mode number 1. Clear? तो क्या करना पड़ेगा आपको? बिल्डिंग का कॉन्फ़िगरेशन बदलना पड़ेगा. कैसे बदलेंगे? By changing the sizing of the columns or changing your entire orientation. अब इसमें वो you will have to deal with architect. आप बोलेंगे मुझे ये कॉलम इतना साइज चाहिए, आर्किटेक्ट बोले इतना नहीं, वो सारा झमेला आपको करना पड़ेगा. As per code, whatever configuration that you have developed with the sizing is unacceptable. Clear हो रहा है?
Yes, sir.
Okay, now go to second mode. Now second mode says that your time period in second mode is 0.989 and contribution of the mass getting involved in UX direction. Yeah, this was not 78, it was 0.0781. So 7.8%. So negligible mass, and maximum mass was getting activated in RZ, that is rotation about Z axis. So that's why you see your first mode in torsion. Now, if you see the second mode, you are getting 98. So this is 0.989 is your time period, and you are getting 0.7454 as your mass ratio. That means 74.54% of seismic mass is getting activated in mode number 2. Clear?
Yes, sir.
That means it is passing your no, it is not passing 90. Okay, let us see. Now in Y direction, if you are going for mode number 3, you are getting UY equal to 0.7665. Okay.
Yes, sir.
So in 4, you are getting 33.9%. No, that is your period, and this is 1.9%. Then mode number 5, mode number 6, you can correlate that. Now you have to check that 90% with this, some UX and some UY. Now some UX means it is a summation of all masses up to that mode getting activated in X direction. So mode number 1, 7.8%, because there is no previous mode, right? So here in mode number 2, some UX is getting 82%, some UI is still 0. Then mode number 3, you are getting 82, where some UI is getting 76. So finally, if you see in mode number 5, you are getting some UX equal to 92.3%, but some UI is less than 90. And in mode number 6, you can see already some UX has passed, and here you can see in some UI 90.4% mass is getting activated. So according to code, you need not worry about mode number 7, 8, 9, etc. Clear?
Yes, sir. Yes, sir.
But this is not allowed. So इस पर मैं अभी नहीं बोलूंगा. आई विल टॉक अबाउट दिस later on. And yeah, see, right now this is not acceptable. That means sizing of your you may go for 300 by 750 outer, and you may go for lesser size in inner. पहले बताया आपको, क्या क्या बताया था? ये कॉलम को निकाल दो, और ये जो है ना वो यहाँ पर ले लो, यहाँ पर ले लो, and you will see that your torsion is removed. कर सकते? कल करेंगे, कल.
अच्छा,
यस, थक गए क्या?
ओके सर.
बात तो यस.
पल्ले नहीं पड़ा सर ये तो मुझे ज्यादा.
हेलो.
ट्राई करके देखते सर.
यस सर.
हाँ, क्या करना है, बस वहां से वो कॉलम डिलीट करना है और वो उसको रिपीट करना है वहां पे. 2 मिनट का काम है. विल डू दैट टुमारो. But anyway, why I am saying that, so that you will understand that if you change the configuration of your building, you can fulfill the codal provision also, right? Okay, with this, I think we'll conclude today's session, but let me see. So, clear हुआ?
Yes sir.
Where is
यस सर.
अविनाश?
यस सर.
तो आज पूछेंगे, कल पूछेंगे?
कल पूछा सर. आज पूछना था ये कि सर वो आप मोड नंबर 1 2 3 दिए थे प्री वाइब्रेशन में, तो उसके अंदर ये आप मोड के अंदर टाइम पीरियड डाले तो वो कहाँ से आया था?
अरे that is what he has analyzed and given you. वो डायनेमिक एनालिसिस फिर क्या किया आपने? ये
सर अभी तो
see what you have done. Let me unlock it. यहाँ पे उसको आपने बताया ना डायनेमिक एनालिसिस कैरी करो.
यस सर.
ये जो सब बताया ना, ये सब उसने अप्लाई करके आपको वो डायनेमिक एनालिसिस रिजल्ट दिए.
ओके सर.
अब रिजल्ट देके वो बोल रहा है आपको ये T1 ये है, राइट?
राइट सर.
और अगर मैन्युअली आपको करना है ना, तो मेरे ख्याल से एक तो सीखने में आपके 2 साल जाएंगे, और फिर सीखने के बाद अगर मैन्युअली कैलकुलेट करोगे ना, तो भी आपको 1 महीना लगेगा वो, क्योंकि यू विल हैव टू क्रिएट द स्टिफनेस मैट्रिसेस, एंड यू विल हैव टू फाइंड आउट द इनवर्स, देन you will have to apply it in your dynamic equilibrium.
सर रहने दीजिए, यही काफी है, नहीं पढ़ना उतना.
तो assume करो ना उसने T1 दिया है, यहाँ से दिया है. With this information, whatever information that you are given through this RSX and RSY and EQX and UQY.
ओके सर.
जो हमने पीपीटी किया ना, वो पीपीटी में हमने नहीं लिया था क्या फर्स्ट मोड 5-1 5IJ एक्सेट्रा IK.
यस सर.
So वो सारा that is what is known as pre-vibration analysis.
ओके सर.
Yeah. Yes. Any other query? See, you can ask me n number of queries. I don't have any problem. ये आपके ऊपर है. फिर भी जितना सिंप्लीफाई करके मैं आपको समझा सकता हूँ उतना मैं कर रहा हूँ. आई एम नॉट इन्वॉल्व इन द मैथमेटिक्स, क्योंकि अगर मैंने मैथमेटिक्स उसमें इंट्रोड्यूस किया ना, तो आप नेक्स्ट सेशन को आप नहीं आएंगे, बोलेंगे सर वो रहने दो. यस, सही है ना अविनाश?
यस सर.
So people are always very much frightened of the mathematics, but I don't know. But mathematics is the best thing in the world. उसके जैसा खूबसूरत कुछ है नहीं. आपको आपको सिर्फ वो अगर फिगर्स क्रिएट करने लगेंगे ना, तो आपको पता चलेगा कि ज्योमेट्री में कितना दम है। तो ये ज्योमेट्री के दम पर ही लोगों ने ये सब फ्री वाइब्रेशन एनालिसिस वगैरह डेवलप किया है। See, the person who has developed the program of free vibration analysis to this ETAP software, वो बहुत बड़ा मैथमेटिशियन है, इसी वजह से he could do that. Theory of probability, vector algebra, then Fourier series, Laplace transform. So all that is included, and that will give you. So when we'll be going for a revision of 1893, मैं आपको उस समय थोड़ा थोड़ा बताऊंगा, सारा नहीं बताऊंगा, इसलिए कि फिर you will be bored. That's why. Is anybody having any query? नहीं समझा ऐसा कि concept? Can I assume that everybody of you have understood each and everything, whatever I have explained? अरे ये भी नहीं,
Yes,
वो
sir.
भी नहीं, तो क्या समझना?
समझा सर, अभी एक बार और पढ़ूंगा फिर ना कल बताऊंगा सर
Okay,
आपको।
okay. Yes, you can go ahead and you can go through the previous. See, मैं आपको again advise करूंगा. Yes, Samir, you want to ask me something? Hello, Samir, want to ask me something? Yes or no? Okay, okay.
नो सर, एक बार
दोबारा?
सर दोबारा से एक बार कोड।
Hello. I'm not getting what you are saying. दोबारा what? I think he's not listening my voice. Some there may be some problem. Okay. Anybody having any other query? Yes.
सर कोई क्वेरी नहीं है शायद, इसलिए नहीं पूछे लोग।
तो ना तो बोलो ना भैया, मैं कैसे समझूंगा? कम से कम ना तो बोलो. Yes, Samir wants to ask me something, but I am not hearing what he is saying. Maybe a connection
एक्चुअल में
issue.
सर वो
Samir will talk.
यस
Yes, go ahead. Now I am able to listen you. Yes. Again that. Yes.
हेलो
Yeah.
यस सर, आर यू लिसनिंग मी?
Yeah.
सर वो
Yes.
कुछ कनेक्शन प्रॉब्लम थी सर, इस वजह से ऑडियो की
हाँ.
दिक्कत हो रही थी।
नहीं
तो
बराबर
सर मैं यही
बराबर.
बोल रहा था, एक बार सर ये एक बार सर रिवाइज करके दोबारा से एक बार ये वॉच करके फिर सर आपसे डाउट्स पूछ लेंगे सर।
Yes. You're free to ask me any doubt in any session or even after the session. Okay.
यस सर।
Okay. Thank you. So with this, I will conclude today's session. Tomorrow we'll be going to apply that load case combination, and then we'll just go through the other details, and that will be the end of our first module. That is about understanding basic concept in ETAP. Okay. Thank you.
Thank you, sir. Good night, sir.
Thank you, sir. Good night, sir.
गुड नाइट सर।
गुड नाइट सर।